I'm one of the co-founders and CTO of Ooyala. A quick little bit about Ooyala, basically by the numbers. We were founded by myself and a couple of co-founders back in 2007, primarily out of Google, and why that was, I think, so important for us was we got very familiar with the types of technology that made that transition to AWS incredibly easy. So as we look back at a lot of the evaluation we made in 2007, that was right around the time where EC2 and S3, at least in our world, was starting to get a little bit of steam. And so we were one of the first, actually we were the winner of the first ever Amazon Startup Challenge, which was in late 2007 and early 2008. And that really set a lot of the tone for our overall AWS usage going forward. Today, what we do as a company is we provide a suite of products and technology to large-scale and even small-scale media companies worldwide. And I'll detail some more of the product in a bit. But as far as size of a company, we're about 180 employees, about half here in the U.S., and remote offices everywhere from UK, Guadalajara, Mexico, all the way out to Tokyo and Sydney. What we find really exciting is that we get to work with some of the best and most interesting media brands around the world. And that includes everybody from ESPN and Bloomberg out to Caracol out in Colombia, Star TV in India, and they're all pushing not only really exciting content, but really interesting experiences. And I'll walk through that in a little bit more as well. As far as size and scale, because I think that's one of the things that everybody's really interested in is what we're doing. Thousands of customers, and that's kind of interesting, but technically speaking, what's exciting is we're reaching over 100 million unique users every single month, and they're doing over 1 billion streams each month. If we put that in terms of, let's say, a CDN, we do over 0.5 petabyte of delivery just for our player, not for the video, just JavaScript and Flash to load up our player every single month. And so we're dealing with incredibly high velocity of request patterns, as well as just overall throughput. So the effective marketing slide here of what Ooyala does, and then we'll get on to the interesting stuff. Think of us as like AWS for video. So we like to think of ourselves as providing a lot of the product components and services that actually make it a lot easier to do video online. And this is everything from content ingestion and transcoding to a lot of the user experience components, all the way down to, let's say, cross-device delivery and analytics. A good example is today we actually run a massive large-scale database store. It's a NoSQL system backed on Cassandra. We're literally in the tens of terabytes of data stored in our system right now. I don't think we made it over 100 terabytes yet of capacity. But that system's literally doing billions of analytics events every single day for all the consumption from our end users. How that ultimately materializes itself, the short version here, is the end view that you get when you go to ESPN.com, or if you watch Bloomberg TV, or if you try to watch any of Miramax's new content on Facebook. These are the ultimate solutions that we provide that all use a large percentage of our modules, but actually are allowing our customers to build some pretty interesting, creative, and engaging experiences for their end consumers. So one of the big questions that we always ask ourselves is, so how do we get from there to here? And in 4 years' time, and arguably really 2 years' time since we launched our commercial product, this is actually our first office. There was actually twice as many desks as we had employees. We had no servers, we had no infrastructure, we had no code, nothing. And so there's a long way to go in a pretty short amount of time. And so what I want to give you guys is a few different pairs of information. First are some of the trends that we've really identified over the last couple of years. Second are some of the problems that we continually see ourselves bumping into. Third is some of the lessons learned, and then actually do a little bit of a deep dive on 2 examples of technology, how different parts of our technology stack work that really take advantage of those lessons learned. So first is the traffic's growing exponentially. A good comparison here is today we will do, just today, more streams than we did in all of October last year. And that's only going to continue to grow. And this is not only compounded by the fact that video online is growing rather significantly, but at the same time, our company is growing even faster as far as overall distribution. And that would be a big enough trend by itself. But as the industry evolves, the scope of problem, the complexity of the solutions we have to build is also getting more complex. Back in 2007, the sales pitch to our customers was really easy. It was hey, I have content, I have consumers, help me connect the two. Right? And we can build a CMS, and we can help you distribute content. The CDNs really were doing all the hard work at that point because they're pushing around large amounts of files. But as I mentioned, now we start to get into a lot of analytics, and we have to build massive, large-scale analytics data store clusters as well as Hadoop clusters. Even further on, as we look into where we're getting now we're getting to even more complex and really fun and exciting problems around content recommendation and personalization, things like multivariate testing around your monetization strategy, things that require a lot more heavy lifting beyond just video transcoding. So one of the problems, of course, is that we're not very nice to our servers. We tend to beat up on them quite a bit. Believe it or not, this is actually a physical server from EC2 that we received from Amazon as part of that AWS Startup Challenge. We beat up on our servers. We push them hard. If you look at the average load, the average CPU consumption on all of our servers, they all tend to run pretty hot. And as a result, they tend to fail fairly significantly, or fairly frequently. The second is that we love surprises, or more specifically, our customers love surprises. So we have events that are very predictable. There's the Super Bowl, or there's the World Series of Baseball high school championships in Japan. We see those coming. We know that's going to happen. But then there's things like Michael Jackson passing away, or the Queen visiting Ireland for the first time in a couple of decades. Those nobody really knows about, and we see massive spikes in traffic and load on our systems as a result. And we have to really be able to prepare for that. So combining some of the lessons learned. The first one is that serviceability is the exception, not the rule. And for all the true geeks at heart, this is actually the uptime of our original master database. It is still running. It doesn't have traffic, but we just can't really seem to let ourselves terminate it at this point. So we just let it keep going. But for those of you who can do the math, it's about 3 years and 10 months. And every year on the anniversary, we all celebrate the fact that it's alive. But for that one server that's been alive that long, we have lost thousands of servers. And as a result, we always plan for our servers failing, of course, not them having 4 years of uptime. The second big lesson learned was AWS is a system that, to a certain extent, is out of our control. You have a networking outage for half of the 8 availability zones in EC2. There's not a whole lot we can do about it, but that doesn't really matter when our customers are paying us for a high-quality service anyways. That's not their problem, it's our problem. That's why they pay us. And so, while out of our control, it's still something that we have to help solve and resolve for them. So before I drop into a couple of the examples, I did want to give you guys a little bit of insight into what we're using Amazon for. The first big chunk is storage. We do about 0.5 petabyte of storage today across a variety of different buckets, and that's in the billions of files. So it's not just large files, but we generate billions of these on a monthly basis that we're shoving up into S3. And we tend to use S3 for a lot of our origin server traffic. So it'll feed, literally today, over half a dozen different CDNs. We use Akamai, CloudFront, Limelight, EdgeCast, whether it's us personally or our customer's own configuration. And it works fantastic for that. I don't think we could have ever asked anything more out of S3 in this regard. The other thing we do is a hell of a lot of compute. And this is actually after we've, as I think John alluded to, we've run into the similar problems is we had a lot of server bloat for quite a long time and have actually cleaned up a lot of that. And our steady state on any given day is between 700 and 1,800 servers running in EC2. These tend to be largest or extra largest because they're doing a lot of encoding or they're doing other work. At peak, I think we've peaked around 3,000 servers at particular points in time. But every single day we're oscillating between these numbers here. About half of those instances are spot instances. And I'll provide some more info onto why we can do that, and that's actually a great way of really reducing a lot of our costs. I always joke with our account manager, I'm always reluctant to tell people how successful we've been with spot instances because it completely hoses the auction model for us. And so I'd rather tell everybody that they're miserably terrible performance and you shouldn't use them. We'll probably get a better price that way. Then the third is, that John also alluded to in his presentation, is the use of multiple availability zones. We're continually pushing more and more internationally. As of today, we already run out of not only 3 regions, US East, Tokyo, and Dublin, but we also run in almost every single availability zone in each one of those regions. And I'll dive into the details as to why that's actually so important for us. But to walk you guys through my first example, one of the challenges is how do we build a highly reliable and highly scalable solution on top of AWS. First one is we make each availability zone completely independent from all the others. So there's no load balancer in 1A talking to app server in 1B talking to database server in 1C. It's a completely isolated vertical stack. You have Ooyala running in 8-ish AZs around the world, and any single one of those can serve the entire world's traffic as far as the data it has access to, the systems that are there, everything from a flash access server or a play-ready server all the way out to a slaved copy of our database. The second is we use extensive load balancing that helps us, one, keep the systems fairly evenly utilized, but also it helps us remove faulty systems very quickly from rotation. Third, we employ multiple layers of caching. So we use Varnish and Redis for a lot of our caching, and not just for performance, but also for some graceful degradation. So if your slave database drops in a particular region, you may actually still want to be able to answer most of the questions you can while you try and bring it back online, and it gives us a little bit more of a buffer. But one of the things that you always have to be careful about is to very intelligently propagate your failed health checks. Ultimately, if our Quova server goes down in a region, we really need to pull everybody that depends on that Quova server out of rotation and get all our traffic routed to a different AZ where they actually can successfully answer all those questions. So what a lot of this actually looks like is, from a global view, it's basic DNS global load balancing. And this is routing to the different regions and eventually the different availability zones. But where it gets even more interesting is how we actually do architecture within a single availability zone. Everything routes to, of course, an HA proxy layer at the top that then goes to their varnish layers. And the varnish layer is also responsible for keeping track of which servers are healthy, which systems are working, which systems aren't. And rather than doing a nice sort of mix and match even within an AZ from all the dependency chains, we actually tend to cluster them. So even if we have one slave database go down in a particular region, we're still able to actually serve a lot of traffic out of that region, and the varnish system just simply keeps track of everything until it can swing traffic back over again. The other example that I'll give you guys that hits on a lot of our spot instance usage is how do we build something for really high performance yet still actually reduce a lot of the cost. And I think that's, the transcoding model is actually something that people have really tried to optimize and invest heavily in and improve the system. We do our encoding and transcoding pretty different from most folks. And I'll give you guys some diagrams in a second, but one of the key tenets of this is we try and distribute our work whenever we can. The more machines you can have working on something, generally speaking, the better. Second is we keep our tasks very, very small. If it's a small task, it can run faster. If the machine fails, you can just give it to somebody else. You actually can detect problems quicker. And then third, when things do fail, we try and recover very, very quickly from those. So in this example, this is the traditional way of encoding content. You take your big video file, whether it's in S3 or anywhere else, and you push it through a really, really large machine. And it'll crank on it, and if it's a 2-hour-long file, it'll take an hour to 3 hours, and eventually you get your resulting formats. Problem is you have to buy or reserve a very expensive machine to do this, and it actually can be fairly slow. The other downside is that if that machine does fail, which eventually they do, you have to start all the way back from the beginning again. And in the early days when we really started to build a lot of Ooyala's encoding system, we'd bump into a lot of these problems, and that created a lot of headaches for us. Where we've really evolved to, while a bit more complex, is actually a really efficient and exciting system to have, where rather than simply uploading a file and sending it to one encoder, any video file, let's say an hour-long movie, that gets sent to Ooyala will literally hit hundreds of encoders. And the reason that happens is, as soon as we get that file, we'll chop that file up into small 10-ish second segments, and we fan those out to an entire encoder farm. Each of our encoders is then able to actually work on this in parallel. Think of it as a software-based GPU, right? We're doing massive parallelization here, but we're doing it at a software layer. And the reason that we really like this is one, the segment is very, very fast. This thing goes way faster than real time. And two, it can normalize the file. So it's actually doing a lot of cleanup. If your headers are messed up or it's a funky codec that a lot of our actual encoders don't know, it can clean up a lot of the system very quickly. And every 10 seconds it finishes parsing and processing, it's already feeding off those encoded segments out into our encoding queue. So they can start working on it very, very quickly. One of the big advantages here is each one of those encoding jobs is incredibly small. It's a 10-second encode. So we can parallelize that very, very quickly. If they, for example, fail, there's no big deal. We'll just send that little task back to somebody else, and they'll pick it up, and they'll keep doing it. What this means is it's very spot instance friendly. Right? We really don't care if the instances come up, if they go down. It actually really doesn't matter to us. So we're just simply willing to pay for the cheapest machine we can get. The other thing is that we do it we can use a very different type of instance. What we actually care about is how many compute units per dollar, not how big the machine is. Because our encoding time actually isn't dependent on the encoding. It's totally dependent on the segment time and the remux time. Because all the encoding we can simply parallelize. And so we're looking for a different type of instance gives us the best overall performance. What that also then gives us is the ability to make really aggressive optimizations for codecs like H.264 without any time penalty. Right? Even if encoding technically takes twice as long, it's all those little jobs in the middle. So if they happen to take 10 seconds instead of 20 seconds, assuming we have sufficient machines, it's really insignificant to us. So what we're able to do is really aggressively optimize the overall quality. Even if it gets us just an extra 5% quality per bit, for us it's actually worth it. And so we get to make very different trade-offs into how we're encoding our content than you would from a pretty traditional model. So with those two examples, questions?
All right. So my question was, where you're hitting the segmenter, if you're going from a high-quality mezzanine to like a flash, that's really easy, right? But if you have things like closed caption or anything like that that's dependent on the timeline, and these things are all completely agnostic and parallel, will you not lose your timeline?
It depends, right? I mean, audio and video are also, very much timeline dependent. The formats that we actually encode out to, we'll do iOS, obviously, regular Flash, and Adobe's HTTP dynamic streaming. Now, of course, the one caveat here is all that chunking that happens, or the segmenting for both HLS and HDS, it is actually a post-remux process where you're actually then repackaging and remuxing those files for that particular format. But that is again, a very fast process. What we do is we actually, in our encoding system, we don't bake the actual closed captions into the video file, primarily because we can do a lot of the closed captioning out over Flash as part of a DFXP file, and we're building an alternate solution that works with iOS that doesn't have to have it in the actual video file itself. Yeah.
You had a slide with various layers of HA proxy, varnish, app server.
Yes.
Geo, Redis. Are those separate instances, or are those layers, or are some of those layers combined onto the same instances?
Yeah, so that's actually a really good question. Early on, when we first started up Ooyala and when we were probably running less than 100 instances total, we would take that entire stack and you literally had everything you needed to be Ooyala on a single machine. Eventually, it just doesn't fit, really, at the end of the day. And so as we scaled more and more, now they all sit on completely independent machines. Everything from C1 mediums up to, I think all the databases I'm sure are massive, C1 or M1 XLs and so on. So the nice part is we're able to actually get very tuned and optimized instance types per service.
How do you deal with your master database?
Good question. So a master database is always a very different problem, right? Master database is actually a single point of failure. When we architected a lot of our technology very early on, we made a very aggressive business decision that said, so if somebody can't upload content, for example, that's problematic. If ESPN.com stops loading because a slave drops, that's a much bigger problem. And so we architected essentially with playback of content being more important than effectively editing or uploading of content, for example. That said, we actually are in the process of moving to a multi-master system today and have had to do very rapid promotion of failed masters slaves to replace a failed master and actually have that process in place that minimizes our overall downtime. More questions?
Thank you. I have learned my lesson. Thank you. I was wondering, how do you keep the data synchronized? You said any zone and any region of the world can serve the entire Ooyala business.
Yeah.
How do you keep them all in sync? Do you not run into the source of truth sort of problems?
Most of the synchronization problems are really solved on the database level. There's a bit around analytics, and our Cassandra cluster already does the multi-data center synchronization as part of it. Our average database slave delay is rarely ever more than 5 seconds. And so for the most part, we're able to have a pretty tightly synced system. Across AZs, yeah. Our slaves all the way out in Tokyo and in Dublin rarely ever are more than 5 seconds behind. And the average, I think, is like half a second delay.
And then to what extent are you using CloudFront at all?
Good question. So we've actually had, to be very honest and transparent with everybody here, so we've had a number of conversations with the CloudFront team. And we think it's a wonderful, fantastic technology. We don't do very much delivery over CloudFront, primarily because our customers oftentimes will bring their own CDN relationship to the table, whether it's Limelight or Akamai or CloudFront. We do delivery out over CloudFront, but it's usually dictated by what the customer prefers. Our primary CDN that sits in front of all of our cacheable player delivery, for example, is Akamai. And they're a very close partner of ours. Any other questions? Oh.
What type of authentication schemes do you guys use for like geofiltering, rights management, anything like that?
Good question. So general security, we actually break into 4 sections. There's authentication, right, which is who I am. Very oftentimes, that's actually not handled by us. It can be. We deployed systems like that, but oftentimes it can be part of the Facebook integration. Next is entitlement, right? What do I actually have access to? And those are usually handled by the same system. We can do it as part of our subscription management, but we also have customers that handle it themselves. And this is part of that having a very well decoupled set of systems. Once you start to get back into the playback side of the world, though, now you're talking to authorization, right? Do I actually have access based on an entitlement? Do I actually have access to this content? And that's where we open up a lot of our APIs around actually signing a request, saying this user is authorized, setting a cookie, and so on, to play back this content. You can do that around iOS, Flash for Flash access. We also generate tokens, and we'll hand those off to the different CDNs like Akamai for RTMP plus tokenized type delivery. And then all of that goes all the way down to the encryption protocol, right? Whether it's going over RTMP, play-ready decrypted content, Flash access, and so on. Any other questions? You two again.
Such nerds. So then is Backlot completely run from
APIs?
AWS? Yeah.
Oh, from the US?
Yeah.
No, so our servers are running worldwide. So, for example, we have systems out in Ireland. We have running out of Tokyo. So the entire service is run globally. And Backlot just simply is a client-side app that talks to those APIs.
I wanted to ask if you're using SQS to distribute as a distributed queue between the chunker and the transcoding engines, and if you don't, then is there a reason why you don't use that?
It's a good question. So we used to use SQS a lot in the early days. We ended up evolving to using our own queues for different items. We use Redis for some queuing. We played around with Zookeeper for a while for different queuing. We settled for our encoding system. We actually built our own queue that's database backed, primarily because we don't have a FIFO, first in, first out type encoding system. There's actually priorities. So if somebody has breaking news, for example, it doesn't matter if NetMovies out of Brazil just uploaded 30 full-length movies. If it's something about Steve Jobs, for example, we want to move that to the front of the queue and get it live as fast as possible. So there's more complexity that we just simply couldn't get out of those systems. Plus, I think that the volume of messages would be prohibitively expensive.
Do you support live ingestion, say like from satellite as well?
We do a lot of live streaming. Ironically, we're not doing this one, but I think we talked about that. We don't do a lot of the downlinking. Generally, where we pick up is the consumer experience. So we have a lot of partners that'll actually, they'll come down with a truck, so they'll do the satellite downlink to you, kick it off to your CDN of choice, whether that's, CloudFront, Akamai, Edgecast, and then we have the ability to plug that back into our player then, and we pick up with, how you're monetizing it with pre or post or in streams. We'll do all the analytics and so on. Exactly. So we'll do everything sort of sans, touching the actual bits of the video itself for the live event. Great. Any more questions? All right. Thank you, guys. Oh.